Hello, my name is Taru Carter, and this is for our CS 232 Exam 3 question where we had to figure out the Collatz problem assignment. Here at the top is what we got from the starter video of giving you the instructions on how to come up with the Collatz number, essentially getting the user's number, and if it is even, you're going to divide it by 2, or if it is odd, you're going to multiply that number by 3 and add 1 to it, and so forth until you end up with the number of terms, which terminates when it reaches 1. I'm going to go ahead and show you the whole code. That's up to line 28. And show you from 28 until 56. And moving along up until code line 81. And then from 81, let's get it down here to line 105. After 105, we're going to bring it down to line 133, and then finally to the end of our code here. Coming up, we did have some problems creating this. Basically follow the video with creating a struct called Collatz node, and we're going to have an item that we're going to place inside of the node of type integer, and of course this Collatz node will be linked adds to creating a linked list. Um, Up here, we have the creation of our first node where we take the Collatz node pointer and we're going to call it head, creating a new Collatz node. We're going to have that head linked to the null pointer. And then we're also going to create a new Collatz node. We're going to name that next Collatz node, and essentially naming the next Collatz node to equal whatever the head node is. So essentially we have created our first node. That first node is named head and also named next Collatz node, which are both pointing to the same thing, which is our null pointer. So this has created our first node of the project. Then we're going to ask the user to enter an integer between 100, from 100 on down so that we can test out our program, and we're going to put that into the user number. This is the part of the problem that I didn't understand to begin with when we were taught this in the video, but now I fully understand this. We start a counter at 0, and then whatever the user number is, and let's say we're going to do how the assignment showed 10. We are going to evaluate each number starting from 0 up until 10 to see how many terms of that particular sequence it spits out. So we're going to evaluate 0. How many terms does that bring us to? And then evaluate 1, and then evaluate 2, and 3, and 4, and so on. Then, out of all of the ones evaluated up to the user number, it is going to take the number with the longest chain and place that into this value. And then, however many terms that spit out, it's going to place that into the max number of terms. That's what this complete while statement or this complete for statement is going to get us. After that, this is the part of the program that I had to do on my own, where in a simple cout statement, we're going to take the number, which we found from above, which has been placed in the number with longest chain. It's going to produce the longest Collatz sequence of and however many terms it produced into this cout statement, and then we're going to see out here are those terms. And after that, we were had to come up with a way of creating a linked list that will store all the terms that was found above and place that into a linked list to be displayed later. So we take the number with the longest chain, and I have assigned that to this new variable called Collatz term. I created a for statement that will continually loop, taking that Collatz term that we have found, placing it into the item of the first node that we first created. Then we are going to create a new next Collatz node, linking it to the first one, and so forth, creating our linked list. Then, after we have added a new node to the one that we previously had, we are going to take that Collatz term, and if it's even, we are going to divide it by 2. If it is odd, we're going to multiply it by 3. and then add 1 to it, and now place that term into, we have just updated what Collatz term is to our next number, and we're going to place that into our newly created node and link that to a new node as we keep creating them up until we've reached the maximum number of terms, which we found from above. After that, we're going to traverse the list. Now, this is where you display all the items of our linked list. We are going to take the next Collatz node and we're going to bring that to the front of the list, naming it the head node. And then so long as the Collatz node, the next Collatz node is not the null pointer, we are going to output to the screen the item which we have placed into each node, followed by an arrow. And then it's going to place all of our nodes into a list being displayed on the screen. Once it gets to the final item, which we have in this if statement, if it's equal to 1, then we are just going to put that item on the screen without the little arrow next to it. And let me go ahead and run this program. My video is getting kind of long, but it took me a while to figure all this information out. So I'm really trying to explain that I fully grasp this concept. So enter an integer. We're going to place 10. We're going to press enter. And as you can see, the number 9, it evaluated 0, then 1, then 2, then 3, then 4. So 9 produced the longest Collatz sequence of 20 terms. And here are those terms. Starting with 9, it is odd. Multiplied by 3 is 27, plus 1 is 28. This is even divided by 2, divided by 2. 7, we're going to multiply by 3, which is 21, plus 1 is 22. This is even, cut it in half. This is odd, multiply by 3, add 1 is 34. This is even, cut it in half, and so forth until we get all the way down to the number 1, which we have found on the screen. Now, we need to go back, and now the last part of the program, we need to delete all of the previous nodes that we have created. And after running the program, you can't see that the nodes have been deleted. I mean, I could come up to the debugging tool and open up the memory location, copy and paste all the memory locations. The trick that I found that works is to just display it onto the screen. So here I have commented out this whole section that I've created here for the memory location before deleting. So I'm going to uncomment all of this section that I created. I'm going to uncomment that. And as you can see, it is basically going to put this bar right here at the top of the section just to kind of section it off on the output screen. We're going to traverse the list again, but instead of just putting the item, I'm going to see out a statement that says the memory location for the Collatz term, put the Collatz item there, and then and this is going to give us the memory location. Go to the beginning of the next line, and then we're going to do that until the entire list has been exhausted. After that, we're going to go through the deleting the nodes process where we are taking the next Collatz node, bringing it to the head. Then whatever the head is linked to, we're going to name that the new head. Go back and delete the previous node, which is the next Collatz node. And within the while statement, we are going to create a new node called node to delete, make that the new head node, link it to the next node, and so forth. I fully understand this. And I'm so glad I took the time and tried to figure this out because after figuring it out, I am so relieved that I can fully understand this. And it just took so long, but I think I have a good grasp of this. So now at the end, we're going to show what the memory location is after we have deleted it. We can't, after we deleted all those nodes, we can't recover them anymore. So the only ones I can get is the next Collatz node memory location and the head node memory location. Let me run the program again. And then I'm going to put in the same term. I'm going to put in 10. Again, it's going to produce the number 9, and it has 20 terms. Here are all those terms, and here are the memory locations for each term. So the number 9 has a memory location of 25040. 28 has 25EF0. 14 has 53B0, and so forth, all the nodes. After deleting the nodes, the next Collatz node in the memory location is now zeroed out, and the head node is now zeroed out, and all of these nodes no longer exist at the conclusion of this program. So let me do one last thing. Let me comment this out again because it's going to produce too many on the screen. And then I'm going to comment this out one more time and comment it out. I'm going to go back up to the top. And this last part of the program says once the chain starts, the terms are allowed to go above 1 million. So I'm going to place 1 million in, and our answer that has the longest Collatz term should be 837,799. So I'm going to run the program again, and I'm going to place the number 1, 6 zeros, and come on, program. Sorry for the 10-minute video, but I'll rather show you that I fully understand this than to not get a good grade with 6 zeros as in 1,000. I'm going to press enter and scroll back up, and we have the number 837,799 was produced with the sequence of 525 terms. Thank you for watching.